Good morning, students. Today we are going to start with the second chapter of geography that is named as the physical features of India. Now, we are going to start this chapter with a little recap of what we have been studying in our previous grades. In grade 6, we learned about the different kinds of landforms, and in grades, we also learned about the external processes that help to shape these landforms. What are these three external processes that cause different landforms? They are weathering, erosion, and deposition. Okay. Now, besides these geographical processes that have created these variety of landforms, there are certain other main theories that are related to the formation of landforms. And how have these processes helped to shape the landforms of India? India, as you know, is a vast country with varied amount of landforms. We have the plateau region, we have the mountainous region, we have a plain region, the coastal plain region, the islands, the deserts. So which are these forces that are going on in the interior of the earth that help to shape these landforms? One such theory has that have been explained by scientists, and most probably a scientist named as Wegener. He tried to explain the theory of plate tectonics. And what is this theory of plate tectonics? According to this theory, the earth or the crust has been formed out of seven major and minor plates. Now, what are these plates? These plates are move around the earth's surface relative to each other like slabs of ice on a lake. Why is there movement in these plates? We all know that the core of the earth is composed of extremely hot gases. The conventional currents that take place below the surface bring heat from the earth's interior out to the surface. There is a constant movement going on there, but it is extremely slow. This movement of molten magma is extremely slow, and this turning over of the conventional cells derives drives the plate movements. The plate movements are because of the movement of this molten magma. The movement of these plates result in building up of stresses within the plates and the continental rocks above, leading to folding, faulting, and volcanic activity. These plate movements can also be classified into three types as seen in figure 2.1 on your screen. One is the convergent boundaries. Now, what happens in a convergent boundaries? Some plates come towards each other and either they collide with each other and crumble, or one slides under the other. So they form convergent boundaries. The next, we have the divergent boundaries. What happens in a divergent boundary? In a divergent boundaries, the plates move away from each other. And in a transform boundary, the plates slide horizontally past each other, and in such cases, they form faults. If you remember, we studied in grade 6 that the Rhine Valley of Europe is a fault valley. Moving on to the movement of these plates, how do they affect India? So because of the movement of these plates, the size and position of different continents, different land masses over the Earth's surface has changed over a period of millions of years. And the evolution of these present landform features have influenced the landform of India. Let's go to a visual presentation to read a little more about this in detail. Now here, what is going to be our area of focus? We have four main things to look up. First, we want to know what is Pangaea. The next thing we want to know is what is the Tethys Sea. The next one, we want to understand the time scale. What happened when the two plates actually formed convergent boundaries, the Indo-Australian plate with the Eurasian plate. And finally, what we want to know is how were the Himalayas formed as a result of this collision. So these activities are going to be formed. To understand this, the first thing we need to do is locate the Himalayan mountains in the Indian subcontinent. And if you can see here in the diagram, that the Himalayas are located to the north of India. North of the Himalayas, we have the Tibetan Plateau, and there is a reason we are mentioning Tibetan Plateau here. Tibetan Plateau was the southern tip of the Eurasian plate. So we need to know about our Eurasian plate. This is very important for understanding the formation of the Himalayas. The Indian Peninsula area itself was a part of the Gondwana land, or it was a, or what was known as, when the Gondwana land split up, it became a part of the Indo-Australian plate. Now let us just see what exactly happened because of the collision of these two plates. So we have the Eurasian plate in the north and the Indo-Australian plate, or the Gondwana land, in the south. About 225 million years ago, all the continents as we see them today were one supercontinent known as Pangaea. Okay, Pangaea was a huge landmass on the surface of the Earth. Now, Pangaea further fragmented into two parts, the north and the south. In the north, we had Eurasia and North America. These formed the northern part of Pangaea. They were known as Angara land. And the later part of it, the southern part of it, which comprised of Australia, Antarctica, India, Africa, and South America, comprised of the Gondwana land. This was the southern part of Pangaea. If you can see the diagrams to your right, you can see the evolution of the continents over a period of years. And this was actually the part of India. It was a part of the Indo-Australian plate, which later on joined, fragmented away, and pushed to the north, drifted to the north, and pushed into the Eurasian plate to form India. So here we have our Angara land, we have Gondwana land, and we have India as a part of the Gondwana land, a part of the Indo-Australian plate, where due to the drifting and the fragmentation of the Gondwana land, we can see a drift of the peninsular part of India towards the north. Now, what was this sea between the two areas, the two plates? This was known as the Tethys Sea. It was a very shallow and narrow sea, and it was comprised of a lot of sediments. Now, let's go to further and view it. So this part of the peninsular area that fragmented away from the Indo-Australian plate and drifted to the north, it went and collided with the much larger Eurasian plate. The Eurasian plate was much larger. Now, it was separated by the Tethys Sea in the middle. This Tethys Sea was a narrow, shallow sea, and it was composed of a lot of sedimentary rocks. So when this Indo-Australian plate collided with the Eurasian plate, the water in the Tethys Sea moved away and merged with the Bay of Bengal area, whereas the sediments here composed to form the mountain ranges of Himalaya. If you can see here that now why did the Indo-Australian plate move below the Eurasian plate? And there's a definite reason for this here, that the Indo-Australian plate was much denser. It was much denser than the Eurasian plate. Hence, it went and submerged below the Eurasian plate. And here you have this Tethys Sea. Going further, the sediments in this Tethys Sea were compressed and they formed the full mountains of Himalayas. Now, if you can see, this is the part of the Indian peninsula that is coming forward and joining which has joined the upper part of this portion, has already merged with the Eurasian plate. Now, how does these fold mountains happen? It's a very simple activity which you can actually do at home for yourself. And if you can take a huge stack of towels, maybe around 8 or 10 towels, fold them and stack them straight one above the other. Then on the either side of the towels, use two heavy books or something else which has weight and gently start applying pressure from both the sides. You will see that your towels start getting rifts or folds. And this is how the fold mountains were actually formed. Because of the merging of the land, there was a pressure on both the sides and the folds were created in the land. Now the higher part of these folds is the antisyncline, whereas the lower part is known as the syncline or the geosyncline. In this geosyncline, you can see there is a depression because now the fold mountains have been created here. The northern part of this peninsula area becomes a depression. And this depression was the northern plains. This depression was filled in with the alluvial soil by the rivers that were coming in from the north of the Himalayas. Now, because the Himalayas are very young mountains, they were very steep. They are very steep. And the rivers that flow down the Himalaya mountains have a lot of velocity. So, due to the velocity, they perform a lot of erosional activities on their way as they are coming down the mountain slopes. And all the erosion, the material, the alluvial soil that they erode from the mountains has come and been deposited in this plain, flat plains. This is a pictorial view once again to make you understand exactly the collision of the two plates. So here we can see the Tethys in the middle, the Eurasian plate on the top, and the southern is the part of the Indian peninsula which broke away from the Indo-Australian plate. So you have this Indo-Australian plate here that is being submerged under the Eurasian plate going underneath. You have your synclines and geosynclines, antisynclines and synclines. You have your fold mountains here, and this depression is that went on to become the northern plains of India. Now let us go back to our diagram, figure 2.2, and you can see the names of all the 7 major plates that are there in the below the crust of the earth, and you have 7 over here, starting from the Pacific plate, the North American plate, the South American plate, the African plate, the Eurasian plate, and the Indo-Australian plate. Now, wherever there are these plate margins, wherever the two plates meet, some of those areas are highly seismic zones. They are the destructive plate boundaries. Why? Because there is a constant movement of the plates at those areas. So if you can see, the Himalayas actually lie in a highly seismic zone. Maybe this accounts for the number of earthquakes that happened in Nepal. And also, if you can see here, Japan also comes under the highly seismic zone. So most of the volcanoes and earthquakes in the world are located at plate margins. Some do occur within the margins, but usually the areas of plate margins are the zones of high seismic activity. So as we have seen from a video that the oldest landmass that is the Peninsular Plateau part of India. It is actually one of the oldest land masses present on the earth, and it was a part of the present Gondwana land. The Gondwana land included India, Australia, South Africa, South America, Antarctica, and Antarctica as one single mass. Due to the movement of the conventional currents, the crust split. And because of this, there was a drifting of the Indo-Australian plate towards the north, which resulted in the collision of the plate with a much larger Eurasian plate. Due to this collision, the sedimentary rocks which were accumulated in the Tethys were folded to form the mountain systems of Asia and Himalaya. Because of the Himalayan uplift out of the Tethys Sea and the subsidence of the northern part of the Peninsula Plateau resulted in a formation of a large basin, a large depression. In due course of time, this depression gradually got filled with deposition of sediments by the rivers flowing from the mountains in the north and the Peninsula River Plateau in the south. And this became an area of flat land of extensive alluvial deposits known as the northern plains of India. Agriculturally, they are the most productive region of our country. In the following pages, we are going to study in detail about the salient features of each of the physiographic divisions of India. We can divide India into 6 major physiographic divisions: the Himalayan mountains, the northern plains, the Peninsula Plateau, the Indian desert, the coastal plains, and the island regions. So in detail, we are going to study about each of these and list their salient features. Before we close the lesson for today, there are a few amazing facts that I would just like to share with you. And the one is that these movement of plates, as I told you earlier in the chapter also, is continuous. It is still happening. Until today, the Indo-Australian plate is moving at a rate of 5 centimeter per year. It is still pushing, drifting northwards. And what is the result of this drifting, continuous drifting that is going on? The Himalayan mountains are getting taller every year. The scientists assume that there are a minimum of 5 millimeter, that by a height of 5 millimeter is added to the Himalayan mountains every year. What evidences do we have of this? This is the evidence of the fact that the plate mountains are continuously moving. So this is something that you need to keep in mind, that the height of the Himalayan mountains keeps on changing every year. And the scientists have also predicted that if this continues, then very soon, instead of 3 mountain ranges that we see in the Himalayas, we might see a couple of more mountain ranges. And this is the end of the first part of this chapter. Now, after you watch this video, students, you need to go back to your TED lesson. Please answer all the questions that are given there, and whatever diagrams inferencing you have been asked to do, please go ahead and do that. As you're not going to be getting the booklets now, so I'm going to give you the questions and parts, and you can start answering them wherever you are comfortable. You want to do it digitally, you want to do it on pieces of paper, old notebooks, choice is entirely yours. And when the school reopens, we are going to get back and get all our work together. So after this, please go back, answer your questions. There is another detailed video that talks about plate tectonics in detail. Please go and watch that. Have a great day and happy learning.